Hi students, so we are going to review a little bit of the 3 common methods for solving a trinomial, specifically a quadratic function. So we have factoring, quadratic formula, and complete the square. So we're gonna check some out and we're gonna see, okay, let's always try factoring first if possible. And if that doesn't work, then we'll move on to either quadratic or complete the square. Complete the square is definitely useful, especially when it comes to circles, right? So if you want to put a formula that looks like a circle into the equation of a circle, you want to use complete the square to do that, and then you'll be able to find the vertex of the center of the circle. All right, so but otherwise you could do quadratic formula and you'll get the same answer. All right, so let's get started with some review problems. So first one. Alright, so like I said, you should be able to look at this and say, oh, okay, I'm trying to solve for x, right? All of these are trying to solve for x. Remember that based on our answers for x, we will know this quadratic function either touches the x-axis one time, two times, or not at all, right? And this is based on imaginary roots. If you get 0 in the square root, of course, then you only have one solution, or 2 answers, which is the common thing to get, right? Okay, so by looking at this, I'm like, okay, let me write down my methods. Oh, actually, I already did. So first one, factoring. So I can already see that I can factor. How can I see that? So I can split x squared into x and x, and then the factors of 6 I know are 1 and 6 and 2 and 3, right? So 1 and 6 I'm going to put right here. And I know that because it's a positive 6, I need to have both of these factors positive or both of them negative, right? So I'm going to go ahead and make both of them negative, because then I'm going to get my outer and my inner, which is negative x minus 6x. So I did indeed get the right term that I need to get. All right, now we're not done because this is set equal to 0, so I still need to solve for x, but now look how nice it is. I already have my 2 cases. I have when x minus 6 equals 0, or x minus 1 could equal 0, and then the whole thing would be 0, right? Because remember that 0 times anything is 0. So here, 6 for x would make this whole left side 0, right? Because 6 minus 6 is 0, so then 0 times anything is 0. Or let this be whatever number you want it to be, but if x equals 1, then when you plug the 1 into here, 1 minus 1 is 0, and of course 0 times that number would still give you 0, right? So both of these are possibilities. Okay, so we've done what we need to do. That's x equals 1 and x equals 6, which means at 1, 0 and 6, 0, the parabola or the quadratic function is touching the x-axis, right? So that tells you kind of where the parabola is at, right? So that would be over here, right, in the first quadrant. Okay. We'll stick to this one. Alright, now we have x squared plus 7x minus 4 equals 0. Can you solve for x? Well, yes, now I can already see that factoring is not going to work. Why? Because if I split x squared into x and the factors of 4 into 1 and 4 or 2 and 2, neither of these options, when I make one positive and the other negative, is going to be able to give me 7x when I do my outer and my inner, right? So factoring does not work. So I'm going to have to do quadratic or complete the square. And for this one, I'm going to do complete the square just for the sake of practicing, especially because it's also an odd term for x, and so it's always good to practice that. Give me a second. Okay. So how do we do complete the square? So we first make sure that the number is on the right hand side, right? So we're going to do the opposite of minus 4, which is adding 4. So now we have x squared plus 7x equals 4, right? Okay, great. So now what do? We purposely are going to add a number. What is that number? The number that we're going to add is b over 2 squared, right? Remember that b is the number in front of x. Why do we do this? We do this on purpose in order to factor, right? So on the right hand side, we're going to also add 7 over 2 squared, right? b over 2 squared, right? Now this is going to allow us to make it into a perfect square of x plus 7 over 2 all squared, right? Why? We talked about this before. If you were to expand it, we're being smart. If we split 7 in half, then when we do outer and inner and add them, we're going to be getting that term back. So if you were to check this, do the work, outer and inner gives you this term back. And then of course I have my x squared, and of course I have the last that I need, right? So this is nice because this is the square root method, and I know how to solve the square root method. It's not difficult. It's just that the opposite of squaring is square rooting, right? But remember, what you do to one side, you have to do to the other. So we're going to add 7 over 2 squared to 4. So figure out what that is. So 7 times 7 is 49, and 2 times 2 is 4, right? So in other words, this is 4 plus 49 over 4. Let's say I don't have the calculator and I want to do this manually. You totally can, and you should learn how to do that. So 4, I'm going to make it have a denominator 4 over 1. I'm going to make it have a denominator of 4, right? Just so I can add these fractions. So if you turn 1 into 4 by multiplying 4, you have to do 4 times 4 to make these fractions equivalent, right? So 4 over 1, do you agree that's the same as 16 over 4? Great, and that means that I can actually add the fractions, okay? So over here, this is going to be 16 plus 49 on top, and then of course the 4 stays the same on the bottom. So let's just add 49 over here, 65. And then on the left hand side, okay, so I'm going to erase in a moment, but because from here, remember it's YouTube, you can go back, you can rewatch it. But from here, we're just going to use the square root method, and you're going to see that it's very easy. And again, it's going to be the same exact answer as complete the square, but as you can see, even though it looks difficult, it is not. All you're doing is you're adding the b over 2 squared in order to get the L, the last part of FOIL. Once you have that extra term, then I can actually factor and complete the square. Alrighty? Great. So I'm going to erase this to have more space. Okay, so here it is. X plus 7 over 2 squared equals 65 over 4. Okay, now to undo this, the opposite of squaring is square rooting. Right, whatever I do to one side, of course, I do to the other. So this is going to cancel out the square, and I'm just going to be left with x plus 7 over 2. And over here, this is plus or minus. Right? So it's going to be plus or minus the square root of 65 over the square root of 4. Now, you may or may not know this, but because both of these numbers, a fraction, is under the square root, I can split it into the square root of 65 over the square root of 4. And why would I do that? Because usually the denominator is a perfect square. So of course you know what the square root of 4 is 2. Right? So it's going to be x plus 7 over 2 equals plus or minus square root of 65 over 2. And then of course, last but not least, subtract that fraction, minus 7 over 2, and you're going to have your answers. Okay, you can also put it in front of the radical if you prefer to. Okay, and again, this is exactly what you would get if you did quadratic. It would be negative 7 plus or minus the square root of 65 all over 2. Alrighty, you always want to try to simplify that radical as well, unless you're allowed to have a decimal answer. But we know that the square root of 65, if I were to break it down, it would be 5 and 13. Those are both prime numbers, so I can't simplify any further. Okay, but if you wanted to get your decimal answers, just double check that you know how to do this, it'd be negative 7 plus the square root of 65 over 2, and negative 7 minus the square root of 65 all over 2. And then just use a calculator and you can finish it. Okay. so that was another review problem that is useful. Okay, very similar to the flicker problem that we did. Okay, number 3. We've talked about this in class, so let's say we have something like this and we don't have the C term. Well, then I can look and say, hey, before I make this more complicated than it needs to be, I can see a GCF. Both of these have an x in common. So if I were to take an x out, you would be left with an x minus 12 equals 0. And whenever you have numbers multiplied that equals 0, you can actually solve for them, right? So this means that either x is 0 or x minus 12 equals 0, and the whole thing would be 0, right? So I already have one answer here, or it could be that x equals 12. Right, so simple problem, I didn't even have to do these 3 methods, any of these 3. Okay, number 4. Alright, let's say you have something like this where you have some terms on the other side or one term on the other side. Remember that you always want to have the terms on the same side because you need this to be equal to 0 in order to do the GCF, right? So right now, yeah, it looks like they have an x in common on the left, but I can't do that because this must be equal to 0 for me to even do the GCF and then solve for it, right? So then here, instead I'm like, okay, I'm gonna have to subtract that 1. And now it's set equal to 0. Now I can either do factoring or quadratic. I decided not to do complete the square because I just did that. And remember, for complete the square, it's actually already ready for you because the number is on the right hand side. But I want to do either factoring or quadratic. So I can see that factoring is not going to work. How do I see that? Because x squared I split into x and x, factors of 1, only options are 1 and 1, right? Because it's negative, 1's going to be positive and 1's going to be negative. And of course, when I do outer and inner, what happens to my inside term? It cancels, okay? But that's not what I want. I want negative 4x. So I'm not going to be able to factor. This was my only option. And so with that, I'm going to have to do quadratic, which is great because we want to review that too. So this is x equals negative b, right? So I'll put my a, b, and c over here. So a is 1. The number in front of x squared, b is negative 4, the number in front of x, and the c is just negative 1, right? So this is x equals negative b plus or minus square root of b squared minus 4ac all over 2a, right? And then now we just have to simplify. This part's not difficult. So what's a negative times a negative 4? A positive 4. Plus or minus. All right, I'll do this over here. So what's negative 4 times negative 4? In other words, this part right here, negative 4 squared, that's 16. And then a negative 4 times a 1. Remember that we do this part first, so we figure out what negative 4 squared is. And then these 3 numbers get multiplied, right? Negative 4ac. So here, negative 4 times 1 is negative 4 times a negative 1 is positive 4. So we're going to be adding 16 to 4 in the square root. So that's the square root of 20, right? All over 2. Okay, so we're not done because remember that you always want to simplify what's in the square root. So what is in the square root? The square root of 20. So let's simplify it over here. The good thing is that at this point we've done this a lot. So regardless of the method that you like to do, you should get 2 square root of 5. Okay, so I'm going to replace the square root of 20 with 2 square root of 5, and I'm happy about that. Why? Because I see that these numbers are even and they want to be divided by 2, so I'm going to be able to do that. So what's 4 divided by 2? 2. And what's 2 divided by 2? 1. So it's just the square root of 5. Right, so these are my answers. Again, if you needed to get the answer in decimal form, you would do 2 plus the square root of 5, 2 minus the square root of 5, and get your answers. So I'll let you look at it and soak it. do some more. Oops. Alright, so here I'm like, okay, all I have is the a term, right? Because remember that a quadratic function is ax squared plus bx plus c, where this x squared needs to have an a that's not equal to 0. In other words, there needs to be this x squared in order for it to be a quadratic function, right? The b can be 0, it could go away, the c could go away. I need at least ax squared. So here I have an ax squared, and then of course I have numbers. So for this, you can actually do the square root method. How do I know that? Well, because I have x squared, and then I just have numbers, right? So I can get the x squared to be isolated, and I know what the opposite of squaring is, right? Square rooting. So I'm gonna just go ahead and subtract 2, so that I can start isolating my x squared, okay? What do I do next? Opposite of multiplying is dividing. So it's gonna be x squared equals 6. And then how do I get x? Well, like I said, the opposite of squaring is square rooting. Whatever you do to one side, you do to the other, plus or minus. Okay, now of course I want to try to break this down, but if you try to break down 6, all you get is 2 and 3, so no couples, they're single. So that's all I can do. So my answer is going to be that x is positive square root of 6 and negative square root of 6. And again, use your calculator if you need to know the actual decimal answer for that. Okay, so this is square root method. I just had the x squared. And then of course I had c, because c is a number. So remember that for this method, this is used when there is no x term, right? No inside term. Alright, see how fast that was compared to doing quadratic? Yeah. Alright, next one. Again, don't get worried if you think the numbers are big. Always try to divide by GCF. Why is that useful? Because if these numbers are super big, but you can divide it by a number, then A, you are going to be able to solve for those smaller values, right? Or B, you're just going to be able to solve it out. Okay, so for this one, let's see if we can do it. Alright, so here, unfortunately, I don't see a GCF between 14, 3, and 2, so I'm just going to go ahead and go for it. Right, so factors of 14, 1 and 14, and 2 and 7. So I'm going to go ahead with 2 and 7. It's always recommended, well, at least I recommend, to try the numbers that are at least a little bit closer in value, especially considering that I'm going to have some more numbers for the last part. Right, so let's see if 2 and 7 work, and if not a big deal, I'll use 1 and 14. Alright. So let's look at the factors of 2. We have 2 and 1. Right. So because it's negative, I'm going to make one negative and one positive. So I want to make the right one negative and the right one positive. Okay, again, if this doesn't work out, not a big deal. I'll just make this positive, make this negative. This is trial or error. All I have to do is use the first and last, double check my outer and inner, and all of these 3 terms should check out. Okay, so when I do my outer, I get negative 4x plus 7x, which is 3x. So we did it. Yay, you see? So we can try factoring. Again, don't think that it's not going to be possible just because you get a bigger number with a lot of factors in it. Oh, we didn't finish solving for it. Okay, so we still have to solve because it's equal to 0. So we're going to do 7x minus 2 equals 0, or 2x plus 1 equals 0. And we all know how to solve equations, right? So we're going to add 2. So it's going to be 2 over 7, or x equals negative 1/2. And you can leave it like that, or you can turn it into decimals, whatever you prefer to do. Of course, decimals if you had to graph this quadratic function. Alrighty. next one. Alright, same thing. I have a over here, I have a number and a term and another term. So I'm going to make sure that a, b, and c are on the same side so that I can see what this quadratic function looks like. Okay, so it should actually be 5x squared minus 41x minus 36 equals 0. Okay, so we can try different things. Again, I'm going to try to go for factoring. It doesn't hurt to go for factoring. Okay, so factors of 5, 1 and 5. I like to put the 5 here. 5 and 1. Factors of 36, there are a lot of factors, right? But I am trying to be strategic about it. So if I were to list them all, you could. Alright, so both here I can see, okay, one of them has to be negative, one of them has to be positive, alright. So I see if I use 4 and 9, right, you could do this in your head. If I were to put a 9 here, 9 times 5 is 45. And then if I'm able to subtract 4, it'll give me 41, right? Of course, I need it to be negative 41, so I am gonna make this negative 45 plus 4, right? So my outer is gonna work out, plus the inner is gonna give me exactly what I need, okay? Again, it's cool to use factoring. Quadratic would give me the same answer, but I wouldn't want to do quadratic with these big numbers. And I don't see a GCF, unfortunately. Okay, so now let's finish solving. So it's either going to be that 5x plus 4 equals 0, or that x equals 9, right? Because x minus 9 equals 0. Alright, so here we have both of our answers. And it's nice when we take our time. Alright, so either x could be negative 0.8, or x could be negative. So it looks like it's a pretty wide parabola, right? Over here we have at negative 0.8 touching the x-axis, and at 9, the quadratic function is also touching the x-axis. Of course, I would still need to know more details. Is it upward? Is it downward? Give me some more points. But at least you have an idea of where you would know actually accurately where it touches the x-axis, the exact points. Okay, and that's the whole purpose of these methods. Okay, and then the last one, I'll do another complete the square. This was the Plicker problem, which is the RVB problem that was done last class. Okay, this is number 9. Okay, and I wrote to solve this by complete the square. So if I subtract 2, I'm going to get it ready for complete the square. Remember that complete the square needs for C to be on the right hand side. The number has to be over here. Okay, so then again, same thing. Okay, I am going to force this to be a perfect square. So what am I going to do? I'm going to use my b divided by 2, so that when I do outer and inner, I'm going to get that term back. And then of course, because of the way 4 works, this number is going to be squared. Okay, so I'm purposely doing this so that then I can factor it, and it would be x minus 5 over 2 all squared. Feel free to check it out if you were to expand it, but this is definitely going to work out. Okay, so of course what you do to one side, you also do to the other. So we're going to have to add the b over 2 squared on the right hand side. Okay, just do the math. So here, what's negative 5 to the second power? That's 25. And 2 to the second power, that's 4. So basically we're going to be adding 25 over 4 to 8. Okay, so I'll pause there for a second. Alright, and I'm going to be adding to 8. So again, I want to have a common denominator in order to add fractions. So I'm going to make this 1 be a denominator of 4. How is that one done? 1 times 4 is 4, so 8 times 4 is 32. Okay, this is a good way to do it without a calculator. You should know how to do this. You don't necessarily have to do 25 over 4. That's how we did it in class. We just turned them into decimals. Alright, but if you want to do it the fraction way, which you should know how because it looks prettier when it comes to radicals, then see what happens. So now I'm going to be able to add the top numbers, right? So that's going to be 57. On the bottom, all over 4, right? Because it's the same 4. Alright, so now what do I get to use? I get to use the square root method, right? Which goes hand in hand with complete the square. Alright, again, you can pause it, you can go back, but I'm going to write it up top so that you can see it better. And I can have more space. Oh, I remember what I was going to say last time, a while ago. That the reason that we also like to divide by the GCF is that if there is a GCF, then that means that now it's going to be ready for complete the square if you wanted to do complete the square. Okay, so for example, let's say, side note, let's say I had 3x squared plus 9x plus 18. Well, all equals 0. Well, I see that they're all divisible by 3, so I can divide by 3 and see what's left over. Okay, now this 3 isn't really important because if I were to divide by 3, it would go away. Divide 0 by 3 and you still get 0. So that's what I was saying, that now you get to work with numbers that are smaller and you're still going to get the same answer because these are just written in different form. Okay, and then from there you can say, oh, I see that factoring isn't going to work, right? And so then you could do quadratic or complete the square. But it's already ready for you for complete the square. Remember that if you try to do complete the square up here, it's not going to work because your number in front of x squared is greater than 1, right? So you're not going to be able to make it a perfect square where you have x plus or minus something times x plus or minus that same something. Okay, so just a side note. Going back to this one, which is our last problem before I prove how complete the square is quadratic, which is very mind-blowing. So here, this is complete, this is the square root method, all right? So what's opposite of squaring? Square rooting. Whatever you do to one side, do to the other. It's plus or minus answers. Okay, so this is going to be x equals 5 over 2 plus or minus the square root of 57 over the square root of 4. Remember in the last problem, you can split these into 2 square roots because I can see that I can simplify the square root of 4. Okay, and over here, of course, when you square root, it's gonna come down, so it's just gonna be x minus 5 over 2, and then I'm adding the 5 over 2. So in case you want me to show the work. Alright, and this is nice because now I have my final answer and they're both over 2. Okay. I have 5 plus the square root of 57 all over 2 because this is the square root of 2 and then therefore I have the same denominator, right? Again, if you were to do this quadratic, that's exactly what you would get. Split it like we did in class and you're going to get your 2 answers. Okay, so the first answer we have 6.27 and the next one is negative 1.27, and that's why we answered D for our warm-up problem and we all got confetti. Okay, so now we're ready for the proof, the much longed for proof. Alright, so how are we going to prove that the quadratic, that the complete the square is the same as the quadratic, but just written in different form? Watch. So it's going to be, let's actually get more space. Okay, so we're going to start off with the quadratic function, the general form of a quadratic function, right? Where we don't know a, b, and c, but this is going to be true for all a, b's, and c's, where a, b, and c are real numbers, right? So first, I'm going to solve this by complete the square. Therefore, showing you that complete the square will give us the quadratic function. Okay, so first what do you have to do to complete the square? Like I said before, this a needs to be 1. If this a is not 1, then I need to divide by it, right? So just in case we don't know what that a is, let's divide by everything by a and just make sure that we just get x squared, right? Okay, scratch that. First thing we have to do is subtract c, because remember that we want to have our number on the right hand side. So let's do that before we do anything else. Okay, now we're going to divide by that a to make sure that we are able to do this method. Okay, so now I have x squared plus b over ax equals negative c over a. Okay, cool. So now we're ensuring that this is going to work out for us, and we're going to make this into a perfect square. How do we do that? You grab the term, the inside term, right? That's related to the variable, just the variable. So, and we're going to divide it by 2. So the question is, what is b over a divided by 2? We spoke about this last time. You can use keep, change, flip. So keep b over a as b over a, change division into multiplication, and then flip the 2 over 1 into 1/2. Keep, change, flip. So this is going to be b over 2a. So I'm going to have to use b over 2a, and of course square that in order to be able to have FOIL make this work out. So if I were to factor this using FOIL, it would be x plus b over 2a all squared. Again, if you were to expand this, check your outer, check your inner, you're going to get this term back. And of course, when you do the last of FOIL, you're going to get this last number squared. Okay, so this is perfect. This is going to allow us to do the square root method. But of course, what you do to one side, you do to the other. So you're also going to add b over 2a squared to the right hand side. Okay, just like we did before. Fraction work, technically you should be able to do that. So again, just keep on practicing until you get it. Remember, to add or subtract fractions, you need to have a common denominator. So just find it, make both of the fractions, the denominators become it, and then of course do the same thing to the top to be consistent. Math is about consistency. So here, we're going to figure out what this is first. So what is b over 2a squared? That's just b times b on the top, and then 2a times 2a on the bottom, right? So 2a times 2a is 4a squared. Okay, so it's going to be plus b squared over 4a squared. Now we're going to try to add these fractions. So I'm going to try to force a to become the common denominator of 4a squared. So how do we do that? Just think about it. How do we turn a into 4a squared? Well, I would need to multiply by 4 and by another a, right? By 4a. But whatever you do to the bottom, you have to do to the top. So we're going to multiply the top of negative c by 4a. So that's going to be negative 4ac. Do you already start seeing part of the quadratic? Okay. The b squared and the minus 4ac. Awesome. Okay, now from here, this is the square root method. And so I am gonna let you look at it again, see what we've done. Before I erase and keep working with the square root method. Okay, so now I'm gonna erase this and we're gonna finish this. So I'm left with x plus b over 2a squared equals, and I'll put the b squared in the front, b squared minus 4ac all over 4a squared. Okay. Okay. Remember, you could flip these terms, put the b squared in the front and the negative 4c in the back, right? They're still being join together. Okay, so now square root method. What's the square root method? Well, the opposite of squaring is square rooting. So we're going to square root, goodbye. Whatever you do to one side, do to the other, plus or minus. So it's going to be x plus v over 2a equals the square root, you can split it, of v squared minus 4ac all over the square root of 4a squared. Now, can we simplify the square root of 4a squared? Of course, the square root of 4 we know is 2, and then if I have a times a, I have a couple of a that can also come out. So the square root of 4a squared is simply 2a. Of course, this is, don't forget the plus or minus. Okay, and then last but not least, I don't want this number, I'm going to cancel him or her. And now it's going to be on the right hand side. So this is where we get x equals negative b plus or minus square root b squared minus 4ac all over 2a. Because remember that this is 2a, and when we got the square root of 4a squared, it was also 2a, so we're going to just write them all over the same 2a. Okay, so this is how we get from complete the square to quadratic function. In case you're one of those that doesn't like complete the square that much and you prefer quadratic, it's really the same thing, just different way of using the method. And this is an actual formula that you can memorize and do, whereas complete the square, you just do the method. You use the b over 2 squared, and make sure you add that to both sides. Factors, square root method, right? You're basically doing all these steps, but you're doing them yourself versus plugging into a formula. Okay, so great job. Keep studying, keep being awesome, and you can do anything as long as you put your work into it. You stay diligent, and you never give up. Okay, so let's erase this. And let's keep on practicing.